Regardless of what an equation looks like, whether it has decimals, negatives, or fractions, you're always going to attempt to solve it the exact same way. Ask yourself the same two questions. What is happening to the variable? When I ask myself this question, I'm analyzing the operations that are affecting just the variable. This would be as if I was attempting to evaluate the equation using the order of operations. I'm looking at just the operations that are affecting the variable. So these can only be values and operations on the same side as the variable. Once I have an answer for question 1, I can then answer question 2. How do I undo the operation? I'm trying to find the inverse of the operation that we found in question 1. Inverse operations, at their most simplest description, undoes the other operation. Addition undoes subtraction. 3 plus -3 gives us an identity of 0. These are two of the most important steps that you can follow while solving an equation. With equations that have fractions, we do not solve them any differently. We use the same methods as if it was a regular one-step equation with whole numbers. What's challenging is the way we perceive these equations. We look at them as being more difficult, when in reality, the only thing that's difficult is remembering a skill that we've already worked on and hopefully mastered. So getting the fear of the fractions out of my head for a moment, I'm going to look at this equation, x plus 3/15 equals 2/3. I ask myself what's happening to the variable. X plus 3/15. Sometimes it's as easy as reading the equation. I'm adding 3/15. How do I undo that? What's my inverse operation? The inverse of addition subtraction. So I'm going to subtract 3/15 from both sides. On the left side of the equation, we know that 3/15 minus 3/15 is going to give us our identity of 0. So we'd be left with just x by itself. 2/3 and 3/15 can't be subtracted that easily. Before we can do anything when it comes to addition subtraction of fractions, we need to have common denominators. You find your common denominator by listing out the multiples. The lowest common denominator is also called the lowest common multiple in many cases. So I write out my multiples. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9, etc. It's skip counting. We do the same thing for my other denominator. So I took my denominator of 3, my denominator of 15. The smallest number in both of those lists is 15. To make 3, so my fraction with 3 as a denominator, into 15, I multiply by 5. I have to multiply 5 top and bottom. So 2/3. 2 times 5 is 10. 3 times 5 is 15. I don't need to do anything to my second fraction because it already has a common denominator, 15. Once I have my common denominators, it's all about the numerator. 10 minus 3 gives me 7, and my denominator stays exactly the same. At this point, I would check to see if it simplifies. 7 only has 2 factors, 1 and 7. 7 doesn't divide evenly out of 15, so it can't be the GCF. This is already simplified fraction. If I wanted to check this, I could plug it back in. 7/15 plus 3/15 gives me 10/15. 10/15 simplified down gives me 2/3. That would give me a true statement. With our next equation, be careful with question 1. What's happening to the variable? In this case, I have negative 18/27 plus x equals 5/9. To avoid possible errors, a lot of students look at that as negative 18/27. We know that we could rewrite this equation as x minus 18/27 equals 5/9. So that's really subtraction. Subtraction and negative values represent the same concept. We're taking away something. So since I'm subtracting 18/27, I'm going to add 18/27. When I add opposites, I get my identity of 0. 5/9 plus 18/27 can't add right away. I need to have common denominators. 9 and 27 are not common. So I list out their multiples. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 27 times 1, 27 times 2. Now, these two are factors. Well, 9 is a factor of 27. So if you know your factors, you may notice there's an easy common denominator here. The smallest value in both lists is 27. One of them already has 27 as a denominator, so I just need to make 5/9 into a fraction or an equivalent fraction with a denominator of 27. If I multiply 9 times 3, I get 27, so I also have to multiply 5 times 3 to give me 15/27. 15 plus 18 gives me 33. My denominator stays the same. Now I can simplify. I know that 33 is just 3 times 11. 27 is just 9 times 3. So I can simplify down to 11/9, and that can simplify even further down because 9 goes into 11 one time with 2 left over. So 1 and 2/9 is my final answer. If you wanted to check your solution by substituting it back into the equation, you can. But your best bet is using the improper fraction 11/9 instead of the mixed number 1 and 2/9. Improper fractions are great for calculating, whereas mixed numbers are better for communicating.